Hi, today I'd like to show you a feature of a PowerShell script I've written that allows you to uh, stop processes from consuming too much memory. The main usage of this is for curtailment of leaky processes, as in processes where a developer has allocated memory dynamically during the running of the process, probably finished with it, but has forgotten to tell the operating system that, as in deallocate it or free it, as we say. So that working set keeps increasing. Fairly common with C and C++ programs which have no built-in sort of memory management, garbage collection type features. Okay, so what we'll do then is we'll simulate a leaky process. You've probably got your own, and then we'll show how my script can control it, albeit using standard Windows operating system features. So first of all, what we'll do is launch the script, which waits for PowerShell process to launch. Obviously that would be the name of your leaky process. I'm just going to curtail it to this session, hence I've got the minus this session option, and I'm going to give it a hard working set limit of 250 meg. So what's a hard working set limit? Well, that's an operating system feature introduced way back, I think in XP Service Pack 2, whereby when you set a hard maximum working set limit, that process is not allowed to have more than that figure allocated to it in terms of its working set. So what happens when it does exceed that, or tries to exceed that? Well, first of all, allocations don't fail, because that would probably cause applications to crash, because the developer asks for memory, not received it, what does he do? Yes, difficult decision. What actually happens is that, let's say I hit 250 meg, I need another 10 meg. The operating system will take the least recently used 10 megabytes of working set of that application and put it into the page file. That's good for leaky processes, because least recently used is probably some of the memory that's been leaked and forgotten about, therefore it's not needed. It can stay in the page file until that process exits or the operating system shut down. But it means the memory allocation can succeed. So we're going to set a maximum working set limit of 250 meg. For PowerShell here, because I've got a memory script that uses standard Windows APIs to allocate and forget to free that memory. So simulating a memory leak. As you can see, I've got existing PowerShell processes, so I've given it the minus new only as well. And I've given it verbose so we can see what's going on. So now it's going to sit looking every 5 seconds, which is adjustable, but there's probably no point making it any more frequent, for a new PowerShell process to launch, which is what we're about to do down here in this bottom window. So here I'm going to start a new PowerShell process using my leaky script, allocating 50 meg every 10 seconds for 10 minutes or until the process exits, because when the process exits, the operating system gets the memory back. So we'll launch that. Bring back Task Manager. We can see my new process ID of 3304, currently a working set of 124 meg. There we can see it allocating 50 meg. Go back to where I launched my monitoring and fixing script from. As we can see, it's picked up this new process 3304 and actually exited, because it's set the hard working set limit. It's done its job. That will now stay in place until the process exits. I can add a minus loop option if I wanted to keep it looping, but as in looking for new instances of those particular processes, as that process specified can actually be a comma separated list. But let's go back over here, see what's going on. Oops. So what we'll see now is that we've hit the 250 meg working set limit that I've put in place, the hard one. A soft one wouldn't have the same effect, but I'll talk about that separately. So what's happening now? Well, if we can see the working set as reported both by my leaky script and also by Task Manager, is that working set is not changing, not going above 250 meg. But if you notice here over here, the commit size, so the commit memory is the sum of the working set for that process and its page file usage. So effectively what's happening is the page file usage is increasing. Why? Well, because every time I ask for another 50 meg, the operating system has to find 50 meg of least recently used memory in that process and page it out. But because it's leaked, as in effectively I've forgotten about it, then I don't need it. It can stay on the page file, so I'm not going to have a problem with over page file, over active page file, extra hard page faults. And that's really all it does. So we'll see that the page file usage rather increases, but working set doesn't. So I'm now saving memory effectively, because I should be up to, according to the script, 700 meg of memory, which is over and above 250 meg. So what's that? 450 meg that has been saved and can be used by other processes or other users if we're talking about Citrix Zen app or RDS. Now what I don't want to do here is apply this to every process. As we'll see in a moment, the number of processes with hard working set limits in the operating system is very low. In fact, if we now use the reporting feature of my script, so just give it a minus report. The warnings in the background are because I'm not running as admin, so I can't get access to interrogate those processes. So if we sort this information, which is very similar to Task Manager, but actually has some extra information over and above Task Manager. So for instance, we can see things like how much virtual memory is assigned, how much working set, and of course these hard working set limits. So let's sort on hard working set limits and see how many processes do have hard working set limits. And we can see there's just one, our particular process with its hard working set limit. So although the feature's been there for a long time, not massively used, mainly because a lot of people don't know about it and it's not easily exposed through tools like Task Manager and things like that, although the APIs are there, as you'll see if you want to examine the script I've written. So that script is available on GitHub, as are a number of other scripts. The leaky script is there as well, albeit in the general repository. So feel free to go and get it and use it in anger to curtail those leaky processes. Hope that makes sense. Thanks.